Okay, so what we're going to have a look at is differentiating powers with fractional indices. Now, we're not going to go through the proof for these ones, but if you would like to, then go through and have a look at your text. But what we're going to do is we're going to write down what the rules are. So the rule that we've been associating ourselves with lately is that ddx of some function of n power is equal to n lots of x n minus 1. And this applies for all real numbers, so including the fractional numbers. So d, for example, ddx of x to the power of a quarter, okay, is equal to 1/4 x to the power of a quarter minus 1, which is the same as 4 on 4. So that is equal to 1/4 x to the power of negative 3 on 4. Okay, so this we can generalize, for any power of n. Now the main one that is going to be popping up a lot is that ddx of the square root of x is equal to 1 over 2 to the x. Okay, so remembering that the square root of x is x to the power of a half, so take the half out and then it becomes negative a half. So it should be a square root of x, not an x. And yeah, it's basically that one. So what we're going to do is we're going to quickly jump in and have a look at a few examples, and then we will split off and do the 2 other videos that will cover the other parts of this lesson. So write each function using a fractional index, then differentiate it, then convert the answer back to a surd form. So y is equal to 1 over the square root of x. So this is the same as y is equal to 1 over x to the power of a half, which is the same as y is equal to 1 over, not 1 over, is the same as x to the power of a negative a half, okay? So if y is equal to the power of a negative half, what we're going to do is we're going to take the negative half down the front for our dy dx. Okay, so if dy dx, so our derivative, negative half comes down the front, we get an x, and then we're going to subtract 1 from the top, so it's going to be negative a half minus 1, so it's 2 over 2 in this case, and I really wish that wouldn't do that. So dy dx is equal to negative a half x to the negative 3 on 2. Okay, so putting all that back in, we get dy over dx is equal to negative 1 over 2 to the x to the negative 3 on 2. So that means that dy dx is equal to negative 1 over 2, and it's the square root of x cubed. Okay, so there is our function right there. Okay, so all the way through, and that gives us our derivative for that one. So then jumping over to this side, okay, let's do this one here. So we've got y is equal to, so the square root of x is x to the half divided by x to the 3. So if I'm dividing indices, we can subtract them from each other. So y is equal to x to the half minus 3. So minus 3 is 6 on 2. So y is equal to the x to the negative 5 on 2. Okay. So to differentiate this, dy dx, we take the negative 5 on 2 to the front. Okay, and then we subtract 1 from the top. So 2 over 2, so it's going to be negative 7 on 2. Okay, so putting it back in, dy dx is equal to negative 5 over 2x to the negative, well, it's not going to be negative because it's on the bottom, so it's going to be 7 over 2. So dy dx is equal to negative 5 over 2. Now turning it back into surd form, okay, so the 2 is on the bottom, so it makes the square root, and it's going to be x to the power of 7 like that. Okay. So with that being said, that's the 2 derivatives for that bit done. So it's just putting them in the, it's just converting them into index form and then turning them back into as we go. So in the next video, we're going to have a look at the chain rule and general indices again, but this time for fractional indices, and then we'll finally look at dividing through by the denominator, which is going to give us some fractional solutions. Okay, with that being said, I'll see you in the next one.